Hey, I would like to talk to you about finding the area of parallelograms. This was something that looks complicated, but pretty easy to figure out if we just think about what we know with area and perimeter of rectangles and triangles. So if you look at this shape and you think about what you already know, what we talked about in class was just kind of looking at this shape as a triangle, a rectangle, and another triangle. Now, some of the students said, if I take this triangle and I kind of cut it off of this shape and I move it over here and I add it back on, so it's here now, which sounds like a lot of work, but what actually happens is I form a big rectangle. I can count the area. 1, 2, 3, 4, 5, 6, 7, 8. So what's happening is I made a rectangle out of that parallelogram, and I know how to find area of a rectangle because area of a rectangle is one side times the other. So I have 1, 2, 3, 4 times 2. So that was a strategy we talked about. So then we started looking at other shapes and realized, hey, I can do the same thing. If I take this off of this parallelogram and I move it over here, then what actually happens is I have this rectangle, which is a 2 by 1, 2, 3, 4. 2 by 4 is also 8. If I count, I get 8. And then I asked the class, what happens if you don't want to draw all of those pictures and count all of those pieces? Is there another way you can look at it? So we started brainstorming and we said, well, what we're actually doing is we're multiplying the bottom, this bottom here, and we're multiplying the side, like this right here. And we realized what we're actually doing is multiplying the base times the height. Okay, so if I go back and I look at this here, I multiplied 1, 2, 3, 4, the base times the height, 2, and I still get 8. Here, the base, 1, 2, times the height, 1, 2, 3, 4. I still get 8. So I said, well, let's try it with this one. 1, 2, 3, 4, 5, 6 times the height, 1, 2, 3, 4. I would get 24. Let's try the other strategy and see if it matches. So I would take this triangle off. I would move it over here. I would multiply 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. Same answer. Okay? So what you're actually doing is multiplying the base times the height. You don't have to draw all of those pictures. If I look at the next one, base, 1, 2, 3, 4, 5, times my height. Now my height is similar to what I would do for a triangle. It always goes from the base to the top and makes that 90-degree angle. And what's different about parallelograms is they always have two bases, because the definition of a parallelogram is that you have two parallel sides, two sets of parallel sides. The top and bottom are parallel and the sides are parallel. They never ever run into each other. Okay, so here I have a top base and a bottom base. I only need one of them to show that the height goes from the top to the bottom. Only one of them is needed to find the area. So 5 times 1, 2, 3, 4, 5, 6, 7. And I don't need to divide in half or anything like that. So my area is just 5 times 7 is 35. This is considered a parallelogram. I have two sets of parallel sides. So I would just do the base times the height. And you can see with this one that my base looks like it's 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, and just half, 4.5 times 1, 2, 3.5. Okay, with this one, this is where we run into the tricky part of finding the height, just like you do with a triangle. So I have 1, 2, 3 for my base, and then I just need to think about how do I get from my bottom base to my top base. That will give me my height. So you don't really count this as part of your base. It is not part of the actual shape. It is just dot, 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 what I need, dot, 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 to get to the top base. Because if I drew a line here, it wouldn't get me all the way to the top. So now I'm counting this as my height. 1, 2, 3, 4, 5, 6. So for the area of this, I would do formula substitution solution. My base is 3. My height is 6. My answer is 18 units. And again, because it's area squared.